Hello everyone. In this video, we draw the PDA for these two languages. First is A raised to n, B raised to 2n, and second one is vice versa, A raised to n, B raised to n. So let's start with the first language. So first we draw for L is equal to A raised to n, B raised to 2n, where n is greater than equal to 1. So if n is equal to 1, that time b is equal to 2. When n is equal to 2, b raised to 4. So in this way. So simply the logic is, let's suppose this string, let's n is equal to 2, that time b is equal to 4, because 2 raised to n, so 2 into 2, 4, so b is 2 raised to 4. So as it is in the PDA, we consider the stack, where initially in the stack z0 is the present. Now on this a is come, so we push this a, but here only 2a are the present and 4b are the present. So how we pop or push these a's and b, so we get at the end acceptance state. So for that we assume when we read this a1, that time we push 2a. So when we read this first a, that time we push 2a in this stack. So this 2a for this single a. Now again when you read this second a, again you push 2a, a. So here what we do, for this single a we push 2 a's and then we read b. So for this first b, this first a is pop, then second b, second a is the pop. So in this way we pop all these 4 a's for these 4 b's, and then at the end again we get the null, then we read null, and this z0 means we are in the acceptance state. So this is the logic for this a raised to n, b raised to 2n. But the same logic is not here for the second language. So this is also we see, but it is later. First we complete this first language. So let's initially q0 is the state. This is the initial state, and now first initially what we read, this z0 is the present and we read 1a. So that time what we push, double a and this initial z0. I hope all you get the idea. When z0 is present initially in the stack, that time we read a, but that this 1a we push 2 a's in the stack, and this is the initial symbol as it is. Now again it is here the possibility is already a is present here, this already a is present, and again a is read. So a is present, we read a, that time also we add 2 a's for this a, and this a is initially present, so this is also we write. So this is the initial a is present, and these 2 a's we push in this stack for this single a. So in this way we push all the a's. So here at the initial state b is not came, because the string itself start from a only, not b. So this is only push operations for the a. Now we read b. So for that we consider the next state. So this is the q1 state, and here what we perform, here a is already present initially and we read b, so that time null the a. So for the pop operation we consider the second state. Here all the b's, so all the a's are the pop. So initially a is present, we read b, that time pop operation is performed, and now at the end we read null, where initial z0 is present, and this is z naught stay as it is, and here we say that we are in the final state. So this is the logic for this a raised to n, b raised to 2n, and this is the PDA. Now we see second equation. Now this is the second language. So here the difference is a raised to now 2n and b raised to n. So for that also the logic is, so in the previous example when a raised to n and b raised to 2n is the language, that time what we do, when one a is we read, that time we push 2 a's. So here vice versa, when we read 2a, that time only push 1a. Means let's suppose n is equal to 2. So a raised to 4 and b raised to 2, we consider this n is equal to 2. So that time this is the string. So a raised to 4 means 4 times a, 2 times b. This is the string. So what we do here, we consider for this 2a only we push 1a. Then again for this 2a we push only 1a. And when we read this b, that time we pop this a. Again when we read this b, we pop this a. And at the end as it is we read null, and when we read null, that time this is the acceptance state. So I hope all you get idea about this. Now we draw here first in this stack. I think no need to show anything, you get the clear idea about this, and if not then also I tell you. First we read a, we push this a, then we read second a, that time we kept this a as it is, nothing we do. Again third a is come, we push this. Again fourth a we read, do nothing. So 2a are the push now in this stack. Now we read b. So first time when we read the b, pop this a. Again next when we read the b, pop this second a. And now we read null, and that time we are in the acceptance state. So now we draw the PDA. So at the initial state, Q naught, here first Z naught is present, we read A, then push the A, Z naught. Now next, when we read next A, that time what I say, here initially A is present, then we read A and kept this A as it is. If we write here 2 variable, that time we push, but when we write 1 variable, then we replace this variable, means kept this variable as it is. So when A is present, we read A, kept A as it is, do nothing. The meaning of this bracket is kept this A as it is, don't push this A, otherwise not pop also, kept this A as it is. Now next state, Q1, here again A is came, then what we do, return the A. So for this example, first A is came, we push. Now second A is came, we kept as it is. Now this third A we push again. Here we see in this example. So third A we push. So for that we write here A. First A is present initially. Again we read A. That time push the A. Third time push. And here we come. For here Q0 state with third time A is read. Now again fourth time A, for that kept A as it is. And if you consider now n is equal to 1, that time also this is what we say, follow the rule. Means let's suppose here n is equal to 1, then to A raised to 2 and B raised to 1. so that time also it is applicable. So when first time A is came, we pushed the A, and second time we kept as it is, and now third time only B is present, then pop the first A, so it is completed. We are in the acceptance state. So this rule is follow for all the even A. Now for the A, n is equal to 2, that time A is to 4. So first push, then kept as it is, second time, third time push, fourth time kept as it is. If we consider n is equal to 3, then A raised to 6. So first time push, kept as it is, second time push, kept as it is, and third time push. So I hope all you get idea about the state for the A. Now here we push all the A's. Now we pop the A's. So how we pop, we know. Initially A is present, we read B. So for that, pop the bracket. So here we pop the A's. Now in the next state, all the A's in the same way, means initially A is present, we read B, that time pop the A's. So all the A's and B are now null. So we read Z0 is initially present, we read null and kept Z0 as it is. And now we are in the final state, Q3. Here is the acceptance state, means we read null, Z0 as it is, and we are in the final state. So in this way we draw the PDA. I hope all you get idea about this. Now if any doubt or any query, then let me know in the comment box. Thank you.